I'm Scott Moser. I'm a technical lead on the Ubuntu server team. Work at Canonical. We are the folks that bring you Ubuntu, and then more recently, the wonder that is Juju and a lot of other tools like Launchpad and BZR and things. But I'm on the Ubuntu server team, so if you've used Ubuntu on server or on cloud, then you've used some of the output of my team. Today the talk is Linux containers, also Lxc. Basically try to explain what a container is, what Lxc is, and then talk about how that's kind of implemented. And then most of my talk is just kind of showing you how to use it and playing with it. We can go kind of interactive and have questions and demo. So Linux containers, wrote up there what Wikipedia describes it as, and then Linux, so that's an operating system level virtualization method for running multiple isolated Linux systems on a single control host. And then linuxcontainers.org, which is the new home of the Lxc project. That is more specific to Lxc, a user space interface for the Linux kernel containment features, as an API and tools to let you use it. Essentially, when we're talking about containers, it's hard to explain. People are generally aware of what virtualization is now in KVM or Zen or VirtualBox or that little one from VMware. Yeah. And people are generally aware of what that is, but containers are like that, but different. A lot of people are familiar with chroot, so largely the term chroot on steroids makes sense to a lot of people. And then also, if you've used BSD jails, I have not. I know that BSD jails are like Linux containers. That's about the extent of my knowledge. But BSD jails are essentially a stronger chroot, as I'm aware of it. And then basically just for the container on the inside, it looks like you're in a VM. You have a set of memory and processes and I/O that you can access, and it looks just like you're a full. You can appear to be a full system and functioning just like a virtual machine, but from the outside, it looks like a bunch of processes. You can actually just PS and look inside the system and see the internals of. And you could like ptrace a process inside there and they just look like processes, just like Linux processes. Let's see. Yeah, so Linux kernel containment features. Over time the Linux kernel has gained features on making a process hanging more and more things off of a process, or being able to put different namespaces on things. So right now you can do that with IPC, which is inter-process communication. With UTS I think you only actually see that when you run uname, or at least that's the most common place. You run uname, see the output of UTS. File systems can be bound into their own namespace, so that processes underneath a given process see a different view of the world than others that are not in that namespace. The PID namespace is now there, so when you run inside a container, the first PID that executes inside the container is PID1. Previously, before that, there was one PID1, and if you were not it, then things were not going to work right. You wanted to be an it. Also namespace is network, the network namespace, so that you can add interfaces and such, and those are then only viewable by a certain process or kind of attached underneath those processes. And the other one that is new, actually, and this is the big thing for Canonical funded some of this, and a big deal towards security of namespaces is the user namespace. Essentially now you can be let's see, the user IDs and group IDs are now namespaced so that a process can have a different view of what what user IDs are. So essentially, I'll show this to you later, but UID 65,000, or a user ID might look like it's number 65,000 from outside the container, but inside the container that UID appears to be 0. So it appears to be root from inside. But outside, the Linux kernel just sees it as a normal process. It's not privileged. And so these are things that that Lxc. Let's see. I should try to explain this a little bit better. I'm going to go back. So for Linux containers, all of this is really just operating system things that that Linux has gained over time. Lots of different ways to kind of like to shove a process, to contain a process so that it's more self-contained, or its children are self-contained and they have less access to other things so that they're more self-contained. The Lxc project is something that IBM started, I don't know, maybe a decade ago at this point. There was kind of a user space tools to interface with those features in the kernel. And so there's a project called Lxc that is now at linuxcontainers.org, which takes advantage, which is that source tree. That's pretty much, that project is available on most Linux distributions. And I think probably up until last year, I think the vast majority of people that had any familiarity with Linux containers had done that through Lxc. Now there are some other projects called, other users of those features were like Docker and Heroku and App Engine on Google also use those kernel containment features in order to safeguard and contain processes. The most popular, Docker is one that is coming up in popularity. I could show a little bit of Docker, but I didn't get to prepare as much as I wanted to for that. But it is a more, let's see, is very quickly gaining popularity as an interface to Linux containers and very popular, and a lot of people using it. So I'll go back. So these are the general Linux container features, the general features in the kernel that allow a process to be, that allow you to do these sorts of things that all of those other projects take advantage of. Now with Lxc can take advantage of AppArmor or SE Linux profiles. You may have seen SE Linux on RHEL or SUSE. They're just a security, a way of enforcing mandatory access controls so that a process can't kind of break out. And AppArmor is the one that Ubuntu has chosen, and it's a similar idea, a different take on the same general idea. But Lxc is able to, when it creates a container, it's able to put a AppArmor profile on it or confine it to a list of SE Linux profiles. Kernel capabilities are a feature that came into Linux, I don't know, 2.6 something, and basically you can now, previously there was, you basically had, you were PID 0 or you were UID 0 and you could do anything, or you were not UID 0 and then you were very heavily restricted. Kernel capabilities were a way that you could, the process that was PID 0 or that had access to certain things could give them up. And so the capabilities are a list of things that you could essentially give up. I've listed some up there like sysboot. Normally that would be like to be able to call reboot. If you had a process that started up as root and then it can drop the sysboot capability, and then no longer, if it were violated or if it tried to call reboot, it would just fail. The syscall is blocked. The same is true for a chroot. You can drop that. sys module allows you to block the modules that you're loading, so that, or that to drop the ability to load modules. Lots of security conscious people will now, across the board in their systems, once the system's up, they'll drop loading of modules. As if you can get the kernel to load a module, then you can go up just about anything that it was trying to do. But so you can drop the ability to load a module. You can drop the ability to net bind service to bind to ports under 1024, and then mknod is the ability to make a device node. There's just lots of different ones like that, and you can basically a privileged process can drop those abilities, and so Lxc is just an interface to all those things.
Do children of that process inherit them?
Yeah, right, and then they're not able to regain them. Control groups or C groups they give you ability to limit memory. They give you access to like kernel accounting, throttling, and Lxc uses it for device node operations. I think, let's see, by default, Lxc gives maybe the ability to create anything, but not to read or write to them. So basically it's just, I think it's just a trick that, that lots of Linux system level containers with an init and would come up and trying to create lots of device nodes, and those would fail all over the place. So they let them create them, but then they're not going to be able to access them. Then the accounting and throttling, you can actually do really neat things. Like you can start a process and attach it to a C group and say this can only do 4 megabytes of I/O per second, right? Or you can limit its I/O operations, and then it can only read or write at its accounted amount. I saw an example of HDParm essentially attaching a C group to it. HDParm has the -T flag or something where it shows how fast it can do I/O to a disk. Just basically tests how fast it can do I/O. And they attached a 4 megabyte per second throttle on it, and it sits, instead of doing 40 megabytes a second or whatever it could, it sits right at 4 megabytes as well. So, you can imagine how App Engine or Heroku are interested in things like that, but they can keep you for your process well contained from having negative effect on others. And also, App Engine, I think Google has funded a lot of work in the kernel and is trying to improve the accounting, and they use that for literally accounting and for billing on process time and things. You can also limit memory, so your process would be only able to mount a certain amount of memory, and then all of its children are anything. Chroots, you can limit the ability to chroot or to change your root. And seccomp policies are, I don't know, it's really probably done a terrible job of explaining what I have explained, but I would do worse on seccomp. It's really weird, and I guess that Chrome uses seccomp in order to to sandbox its plugins. So, and it really hardly limits what the plugin can do. It basically, it's very, very stringent, and it's almost hard to believe it's almost hard to see how you could be do a useful container in that sense. That something could make use of. So now I'll just go ahead on to the hello world for Linux, for Lxc. It's hard to not use the words Linux containers or Lxc interchangeably, since now the domain name is the same, but they're really, it's a very convoluted namespace. Let's see. is my presentation in LaTeX that I learned 2 months ago at Bug. So it was real. Then late last night, I bothered Will to give me a quick link. Let's see. So earlier I had done this, and I had also rebooted. But basically, if you're interested in playing on Ubuntu, this is on Trusty. The majority of the features here are usable on Ubuntu Saucy. And there's actually a daily PPA for Lxc, for Saucy, or for Precise, and you can get all the features except for the namespace features, which is new in the 3.13 kernel. So essentially you have to install Lxc, and you have to add CG Manager for the namespace stuff, which will, again, we'll get to that, but that's new, and so it's not all just wonderful yet. So have to install that, and then let's see. The first thing we'll do is oops. I'm gonna go ahead and copy and paste that. So there is Lxc. Where is that? Lxc create with a template of Ciros, and name it source-Ciros, and then pass on to that template version equal devel. What that did was hit the link there that's shown and download this tarball. Ciros is a little tiny little OS that I develop in order to, it's Linux based, but it's a small root, in order to do things like this, to easily have a tarball that is downloadable. It's tiny, yeah, it's like 4 megabytes, and then you have a full, generally functional Linux system. It gets used on OpenStack a lot for testing. It's really just to test something, and it behaves in a lot of ways like a more real Linux. So now if I do LXCLS, I see that there's a Linux container called source-Ciros. It's stopped, and it's not set up to auto start. So now what I'm going to do is so that is, so there I said clone that snapshot and make a new one called C1. Always when I do a template, or when I use a template, I always just make a source one, and then I make snapshots off of that. You don't have to. You could boot source Ciros just as it was.
Source is just a source for copies.
It's just the name.
Source code.
Right. Yeah. Just the name. Yeah. Yeah. And then, so now I have, now if I, there's 2 of them there. It doesn't show it doesn't show the parent-child relationship, but so, and then what that did is now there's 2 directories in varlib Lxc, source and C1, and then C1 has, and it created a config. Oops. That's the Lxc config. And then when I did that before, I cloned it with snapshot, and snapshot is a bad term for what happened, but rather than doing an rsync or a full copy of the root directory, what I actually have now is an overlay FS that points back to the original one. Lxc can do a snapshot via either LVM snapshots, where it really got the name snapshot, Btrfs, or overlay FS. think in terms of OverlayFS, if you're not familiar with that, it's a union file system, which basically writes every time. So this is my root here, and what happens is any writes that go to it will end up going over here. So I end up with a sparse file system at delta 0.
Is that a copy on write?
Yeah, it's a copy on write at the file system level, whereas LVM and Butterfest would happen at the block level. Yeah, it's a really neat. It works really wonderful for a lot of things. There's some issues with OverlayFS. And it's performing like a normal file system. Some things just don't work, and the biggest thing is iNotify. Not that for the vast majority of things you won't know, but for things that use iNotify, they will not work, and you'll wonder why things don't work. So let's see. Let's go ahead. I think. Let's see. Go ahead and start that up. So start that up, and what Lxc start did there was actually launch a process. Was create this container, attach a network device to it, and then invoke /spin init. You can actually run any program you want inside of there with the defaults, like the Cirrus template does, or the Ubuntu template is to run spin init. And literally spin init, and PID1 is just a process. It's not at all special in there. So it's no different if you told it to run /bin/bash. Your bin bash will be PID1. So there.
Then you wouldn't have Getty running and all.
Right. Yeah.
You just have a shell.
Yeah. And so and that's useful, and you can actually, let's see. Yeah, so then Lxc attach then put me into the same namespace as that container was at and ran the process I told it to run, which was nothing, so it defaulted to my shell probably. Yeah, it must have also been sh because bin bash isn't there. So there, basically, what we've got here in this container is. There's a bug in Cirrus there that it has local echo onto the display, so that's why it shows runtime twice. And essentially, there's a full operating system. Let's see. That looks like it looks like just a normal booted Linux, and for all practical purposes, it is. Let's see. I have devices in /dev. I do, I can't think of a node name. But then if I do from outside, let's see, maybe this. So I just did a.
You just sleep inside.
Yeah, so I did a sleep inside. And now outside, there. So and then you can see the process, the process tree there too. So that just from outside, that's just a PID. So if I do outside, that PID is 30,873. I shouldn't have done that. Cubs win is the password for Cirrus if you're ever interested in hacking it. Let's see. Oh yeah, sleep. Now we'll do that. That's so smart. And then again over here, that's bit 32018. but inside it's PID 123.
Could just do a PS,
Yeah.
there's not many processes.
No. Yeah. So yeah, and then I can actually, let's see, I can. So there is there, and then I can see that, you know, he's running and he's got that IPv4 address. And now I'm in, yeah. And so Lxc had set up, it set up the networking. There's a it puts, you know, it adds a bridge by default, sets up the Lxc BR0 bridge, and then by default it puts MAC addresses off of that. So
that's from the outside, right?
Yeah, that's outside. Yeah, inside. Yeah, I mean it's really neat. Yeah, yeah. You can have him name him whatever you want it to. Networking is kind of funky. Anytime when you're interacting with devices, it's weird because they're not the same as as real devices, but largely things just work. So let's see. So that was general hello world and just functional. Okay, so as we saw when I can reboot from inside there.
And that's just rebooting your...
It reboots my container, right. That was a feature a couple of years ago where that was added. And so that, yeah, because if you were able to call the reboot syscall inside the container, it would have popped out and got the host. Clearly a bad thing.
Is there actually another kernel running?
No, yeah, good question, yeah. Yeah, so the big thing, the difference between KVM or virtualization and containers in general is that we're sharing the same kernel, right? So if you think about it, see, if you were interested in running like an Oracle database, well, Oracle database isn't going to be certified to run on anything other than an Oracle Linux kernel, right? So if you started your container inside there and inside Ubuntu and you had the Ubuntu kernel running and the Oracle database inside, it's not going to be certified. For the past couple of years, that sort of stuff matters less and less than it did. It's really amazing how little that matters. But clearly, you are running a different kernel than the operating system was built for. There, you know, you're not going to have anybody really promise you that stuff's going to work as. But that said, you know, Cirrus, yeah. So Cirrus has I have an Ubuntu kernel, but it doesn't matter. You can run a Fedora container. You can run CentOS containers and anything.
But you're only running one kernel on the system.
Right, yeah.
So what are you rebooting then?
It doesn't, yeah, it basically kills PID 0. The reboot ends up killing, or PID 1, and then it just restarts the container. So yeah, it's a trick. But memory should be set back, and I mean, it basically, it restarts the container. Yeah. So now, I need to fix that, but I shouldn't have to do -kill. The Ubuntu containers, you don't have to do -kill, but so what I did there was to stop it. I did stop and then -kill, and all then Lxc just actually sends a kill to the PID and it's done. So let's see what else was there. Yeah, and then if I wanted, so now. So right now I've still got those two containers, but now they're stopped again. Lxc destroy. now it's gone. Yeah.
So is the original /dev tree
No.
populated when it gets it, or has to be populated by init?
Yeah, it has to be populated by init, and that's what I mentioned, a little trick that I think they play where they allow the init system to create device nodes that it won't be able to access. Because, yeah, init systems basically expect that they're going to be able to do that, make those system calls, but then they fail. Yeah, so yeah, there will be and UDEV, or kernel nodes kernel, let's see, what is it, kernel device events don't populate, what's that called? There's an event queue that the kernel has, and those don't get passed in, and if they did, you could wreak havoc, so.
You've got your source, that's like a master directory.
It's really just a,
It's like a distribution.
yeah.
And you clone it, which just kind of makes a lightweight copy of it.
Yeah, and if you don't do my snapshot, you get a full like rsync copy,
Okay.
right?
So if you go with the snapshot version of it, do you, if you add something to the master one, does it propagate?
No. So the way OverlayFS works is it actually, here, let's, I'll try to show this better. So let's see, so right now, those are all the files that have been created inside of that container. And so all it does is when it is the overlay takes, if I open a file and start to write to it, they get written elsewhere. Let's see, so yeah, and then so I can do, that's actually demonstrating another point is that the file system is shared. So I can say, so this is inside the container here. Control C doesn't work. I think that the fact that I get local echo and Control C doesn't work are related.
Well, we know what he's gonna be doing next week.
Yeah, this has been, I'd like to have this fixed, but yeah.
So that's just something going on inside your Cirrus.
Yeah, it's not got dev console correctly set up. It's interesting because in a lot of ways, so Lxc, the way Lxc creates containers is different from the way libvirt creates containers. And so the devices you get inside, you kind of have to poke around and kind of support both of them. So I initially had gotten Cirrus to work well inside of containers created by libvirt, and then I tried to get them into Lxc, and there's more work to be done. But I mean, it's essentially a platform in a lot of ways, and unfortunately there's no standard container platform at this point. So now, inside the container, there's that foo there, and then
So that's it.
yeah, that's
Main host.
right, and then outside the container, that file's there.
Okay, but if you did that in C1. If you had done that in source, would it be available to both?
Yes, but not so well promised. OverlayFS uses like it's got like blackouts, and I mean, if you can imagine how you'd have to implement this. So if I do create it, it'll be fine. But if the container had deleted that file at one point, So if the host had the file, if one file existed in A, and then B deleted it, then there becomes like a blacklist that says, hey, don't show that file. And then if you delete it in the host, and then recreate it, it's not gonna again pop up. So overlay FS has some, I mean, that's just, it is what it is. It's not something you can really deal with. It makes it really ineffective for like shared things. If you, let's see, apt basically is a shared database, and if you tried to apt-get update in the host and apt-get just upgrade in the host, or in the one with the overlay over the top, now your package databases are completely different, and it's just, you kind of have to leave a single source that you go from. Now Btrfs snapshots allow the host, they're actually literal snapshots, and the host file system could then go off in a different direction with its block level snapshot and so you could update, and they wouldn't have negative consequences, but they wouldn't share the files. Yeah. So let's see, we'll go. So now let's see. So that was the Siros template. Essentially, what templates are just a way to create a container, a plugin that creates the container. There's also one called Ubuntu that does a debootstrap and creates Ubuntu. There's one called Fedora that does a fed bootstrap, I think is what it's called, but basically yum install, and then you can get a yum or a Red Hat base root. You can do that, and actually the Fedora one works on Ubuntu, but in general, I mean, if you can imagine trying to, bootstrap a different OS in the same kernel file system, or in the same kernel, lots of times things don't just work. The first thing that fails if you try to install yum or to do the Fedora bootstrap on Ubuntu is you don't have the RPM command, so it's not going to work. But then if you have to install RPM, they've done a lot of work to make that stuff kind of work. But it's much easier to download, and that's why I started the Siros template a while ago, and then recently with now all the templates that are in the upstream source, LinuxContainers.org now has as downloadable, so that they've built them in a more pristine environment, and you can just download the result of them, which makes things a lot easier. Try to show that. Oops. That failed. Oh, nice. So there's a list, and so what I did there was just
It's a list of the snapshots that you can do, or the templates?
yeah. Gosh. So those are so this was a query of what was available for me to download. That's the download template. Essentially calls to LinuxContainers.org and says, hey, show me a list of stuff you have. And so I didn't realize that CentOS was there. I was planning on doing that, but let's give CentOS a try here. So now instead of, I can say, I think that's right, and all I did was, that's listed in the output, so. Oh. So now it's going to Linux containers that are going to download the thing and extract the root file system. And then assuming that functions, I have no idea how big this is. I don't think it was actually there yesterday, but it might, maybe. So yeah, I'm on a reasonably fat pipe there, that wouldn't have come through the library that quick. So yeah, so then it says, yeah, I've created a CentOS container, release 6, MB64. Let's see, clone. What did I name him? Oh, X, nice. X2, X1. And see, since I didn't snapshot, now that's doing a full rsync right there, or I don't know if it does rsync or copy, but a full copy of the file system tree, so it's, you know, as you can see, a lot slower. And the IO is whatever, so what's going on right now is,
Are you running this on your laptop, or is it USSH to do a server?
this is a service on, it's a server on Brightbox. Yeah, that's why it's reasonably quick.
So speaking of, so one of my questions was, you know, okay, how snappy is this? Is this something you're gonna see a lot of overhead with, or are you gonna?
The performance is really good compared to a container. I mean, there's no emulation, there's no IO. IO is actually IO just as a normal process. I mean, actually, yeah.
Every app I develop, I do it in its own Lxc, and on a daily basis, I have 4 or 5 running, and I don't notice it.
Really?
Yeah, I mean, like every Python app, every Node.js app, everything I run in their own containers so that they can have their own dependencies, their own, like, you know, each of them has their own backend. One needs Postgres, one needs MongoDB and Elasticsearch. And if I shut down a container, those things go down with it. They have their own PPAs, so I can install, you know, the nightly version of something in one container and not affect what version's installed in another container. We're doing app development in multiple projects. It's amazing, and the performance it's native. You don't notice it. It's running on your disk using the same kernel you've already got running. There really isn't anything that's like, oh, this is slow or a hit.
Yeah, and it really, essentially, that all the stuff that all the kernel path that you're going through to invoke this is mostly you were traveling through it if you were not using containers, right? It's all generic kernel things, and so the risk is that by enabling more and more namespace stuff, you actually slow down the non-namespace path. But largely, it's just they're just normal processes. Just like, you know, Firefox has 6 different threads or 10 threads or whatever, you know, they're just processes. Yeah.
He brought up a question. He's running Mondo on one and DB over here and something else over here. How hard is it to pass information between them?
So you can, you can create a container that would share IPC, you know, like IPC or file systems with a different container. The tools, they definitely do allow that. I could actually share the same file system. I could bind my home into the container, and then the container can see it and operate on it.
They all have their own network address though. So if you bring up a database server on one container, it has an IP address. So you can take your other container that has your app and point it at that IP address, and it'll talk just as if you had 2 virtual machines on the same network.
But do you have the trigger that says the database has found your answer? No, the database has found your answer, here it is.
It's just like that.
Yeah, it's just IP, just like I SSH'd in there. I mean, so you can, by default, the things here, they're as isolated as possible. But you can start to share more and more. I can share a file system throughout all of them. I can share, I can share a Unix socket, maybe. I mean, just more and more things you can share. You can choose to share and choose to let things go. But by default, they're made to be more isolated.
You haven't partitioned your total RAM, have you?
No, you can't. Right. They're just processes. I can limit how much memory one of them would have. Right, but by default, again, it basically, like, it doesn't, see, nice.
You're just a container, shut up.
How about Route 1?
Oh, no, I wonder if I'm just completely out now. Come on.
All the players too.
Okay.
You just
Oh,
booted CentOS,
that was Win.
right?
Yeah.
No, this is, there, okay, good, finally. So this is, yeah, no, this was, this what I booted was,
CentOS up there.
yeah, right, CentOS, yeah. So now, I mean,
But how can that be running them the same, you said it shares the same kernel?
shares the same kernel, and so all of it, like, you end up having, you know, its init has kind of got to be made aware that it's not really init, but, you know, the common distributions are getting there to basically allow it to run the container. And yeah, I mean, it's, I'm running, for all practical purposes, just as if I had installed Ubuntu's kernel on top of Fedora, on top of a CentOS and booted into it.
So is this running, is it in RAM or on disk, and how do you allocate, you have to allocate that?
Well, by default, like, there's a file, you know, what happened here was when I created that template, when I create a new Lxc container, I created this directory, because I called it X very badly. And inside X, there's a, you know, that root of S, and underneath there's a whole root file system. Yeah, and then, you know.
So you could like go look at syslog, you can go look at like the var log, syslog in the
Yeah.
container, and see that it's, the container syslog has nothing to do with your outer system syslog.
Where's all that sitting, on the disk or in RAM?
Yeah, so this
On the
is
disk, it's
half on
just,
disk.
yeah, it's just a file system. I mean, it has, you know, this process, come on. This process is to Linux, just a process. Yeah, that's a decent view there. So, you know, outside, you see that, and these are the only PIDs that, you know, those are the only processes that are running inside, and there's the top from the outside. I saw that, you know, that top running. So, yeah, it's kind of hard to get your head around, but it.
So does it have access to all the files on the host system?
The container can't get out. I can, but the outside can get in.
And so if, so
Unless you
all
allow
these
it.
files are gonna go into one file on the
No,
host?
they're in a file system tree. So right now, so this is, here I'm outside, right?
Oh, okay.
So here I'm outside, and here's where the root divide, that's where the root file system is. So if I said,
Okay, I got it.
You did an RC copy, so it's a real copy.
So it's a directory, essentially, is
Yeah.
what it is. It has a directory,
It's got its own file system, it's just, the root of it is inside of another one.
It's just a.
Right. It's
a
got its
folder,
own tree, you can edit those files and they will only exist inside the container. It changes the way you do things, it's amazing.
so then,
If you use the truth, that's really no big deal.
right.
Most people aren't.
No, it's still there because it's persistent, you wanna be able to bring it up and shut it down. It's-
And then, so I can, yeah, and so I can say,
As long as it's a regular system, as long as it doesn't bring your kernel down, it'll be fine. There's a delete command. Lxc destroy, yeah.
there. So that's inside, you know, inside this is watching, you know, I was outside in Barley Lxc rootfs, and I'm tailing a file called root/foo, and inside the container, he's writing every 1 second to what he thinks is /root/foo, right? Yeah, it, so there, I was gonna show with Debian, but I actually, the CentOS is a more interesting, because it's further off. Yeah.
So what would be a good use of containers as opposed to just a virtualized environment?
They're significantly lighter, right? In that, you know, every time you do a write from a virtualization, from a KVM guest, it passes down through through KVM to the host kernel, to a file that's backed file, and then all the way back up. Whereas in the container, the write is the initial write. There's much fewer layers in between there. You're not, it just overall, it's going to be less overhead dramatically, but with that goes security. So up until recently, I mean, largely people have always said root inside the container is root outside. Nobody's made hard promises that if you gave someone a root process inside a container, that they couldn't get out. At this point, and that's probably still mostly true, where most developers would say you can probably break out. There aren't known exploits. Lxc, as it is right now, when it creates a container, there are no known exploits, but you're sharing a kernel file, so you're sharing, it's just kind of not expected to be as robust as you'd like. But with 3.13, there was work gone into user namespaces. So now, rather than root inside the container, effectively being root outside the container, root inside the container can just be a random user ID. And if you did in fact break out of your container, you then have privileges of that normal user ID.
That seems cool. A great feature.
Yeah, it's really neat. So in order to do that, this is on Trusty, and I mean this will come down the pipe, and it'll be available in 14.04 at release, and you can get it right now as I'm showing. But I'd install CG Manager and then reboot, and then go ahead and walk through this. This is.
So you have to reboot your server.
Yeah, you had to reboot the system because, I mean, I think in the end CG Manager will just be there, but yeah, I'm not real familiar with why that was necessary, but so let's see. I don't like that it changes my dashes to whatever the double dash is called when I copy and paste it. So these are the two steps that were necessary. What this basically does is tells that, so in order to do this, I had to be root, because I'm accessing modifying the permissions for that user, so that I basically own the UIDs and GIDs between, what's that, 100,000 and 165,536. So all those are mine. And then this one too. And then that wasn't good. It also should change the normal frame. did there was basically in order to do this, there's now one, if you're doing user namespaces in Lxc, there's now one set UID root program. Is it? Lxc-usernet is it. I think it's down. But Lxc-usernet is the only set UID root program, and so in order to put a NIC onto that bridge, you need to be root. So basically, what we've done is configured that the user Ubuntu can create 10 virtual Ethernet devices on Lxc PR1. Yeah. And so, let's see. Now, so that I did there, and so yeah, so we don't need any sudo, but okay, well, we need a little sudo. In the future stuff, ideally the OS will be already provisioned your user a set of sub-user IDs, and you'll all be set up well there. But once that's done, I think that will eventually just disappear. Just copy and paste when we do this. Yeah. Although then I have to backslash the dollar signs. All right, so now look about right. So now I didn't sudo that. And so now, instead of creating the files down varlib Lxc, it's going to create them in /.lxc. And all the files, yeah, this shouldn't take too long. That's a 80 megabyte download or so. And then if we were if I failed to do a good job of explaining how the processes work and the file systems work, then the namespace is even going to, the user namespace is even going to be more odd. So now, what we've got there, okay. So now in my go. Here it is. So now, instead of being in varlib Lxc, they're in my user group, in my user's home directory. And now, let's see, root. And there. Now, normally those those files would be well, if I. Normally that would look like that, right? Root or 00, but now instead, from the outside, they look like they're owned by PID 100,000. Nice.
You didn't refresh those?
No. What was that?
Was it, have to change where your Lxc root was?
It is related to this, I'm pretty sure. Come on now, please. That might have.
I just got that error the other day. I don't remember what it was.
It might not have helped that I did it with sudo first. No, that shouldn't hurt. Gosh.
say Udovich?
I know why it is, I hope. Come on, please. There. So a lot of that stuff, so all those failures you see on Ubuntu starting up are kind of basically the system not really handling the fact that it couldn't make device nodes, or, you know, it just, but it's not perfect yet, you know, and he kind of gets on with life, but so now, inside the container, I see, I can, you know, echo foo into /var. Nice. Okay. I think yeah. Hitting Control C is ending up hitting the init, which is causing it to echo foo into okay, that should be
So inside they appear like they're owned by user 0.
yeah, we're gonna do this. And I can't stop my fingers from typing sudo when I type Lxc, because, so now let's say, Ubuntu. Okay. Do it. Okay. Okay, that's what I meant. So now, inside, you know the flag for numeric UIDs? Anyone? Oh, well. Yeah, okay. There, so that's 0, 0, right? And outside, that's it, that's owned by that. Yeah, so, but inside, that ID is mapped, so he thinks, yeah, so, and largely, so that means, yeah, I can do operations as root that normally you need something like fake root or, you know, some other toy to do. But it's all contained in the kernel. The kernel's doing the mapping for me. So that is really neat, because now we've got this container and I'm root inside, and root for all practical purposes inside that container. But if I were to get out, I'm just a process. It'd just be a, you know, same as any, you would still gain the benefits that, you know, normally we don't run services as root, so that they don't have they run them as a normal user to avoid what they can do if they did break out of the, you know, like Apache runs as nobody. Yeah, right. I go one more little thing. This is the Ubuntu Cloud is another template. Okay, so that so now instead of downloading the little Ubuntu one, we're actually using the same image root file system that we do if you run an instance on Ubuntu or on Amazon or HP Cloud or Azure. It's file system level identical to what you get there. So, and in doing with that, and because you did that, it's got inside of it a tool called Cloud Init, which is what people use in order to initialize their instances on Amazon to take their generic image into something customized to their taste. And we should be able to then okay, so it's going to so now, let's see, this my user data is just a file that, this is Cloud Init syntax. It just says, set the user's root pass, or set the default user's password to password with an O, don't expire it, allow SSH password off, and then run these commands. So now I can say, so now when I clone that this time, meant to do, yeah, oh there, so it is rsync. User data, oh yeah. My snapshot.
Triple dash.
Yeah, 3 dashes.
All right, this 3 then. There.
See that one?
You can see that, yeah, that snapshot, that did the overlay of that snapshot. You can see, it's magically super fast. And now, and so now, what that did was put the user data that I gave it inside of the container into a place where Cloud Init would then find it. And I bet that's a cut and paste issue. But he tried to run it, but it failed. So anyway, yeah, that Python stack trace is is saying that stuff didn't work. But normally, what should have happened was seen something. Gosh, I got so many. What we should have seen was like a message that just said "Hello World." But so by using the user data and passing it in, you can essentially, externally create something that will run on first boot. And then start your container up. That way you could build some software, write the software to a directory, and then shut the system down. And then once the Lxc container is shut down, then you can copy the output out. So by doing that, by having a way to say, hey, run this code after you've started, you can basically automate so many more things. Versus I think generally it's a nice thing to start a container and then log in as root and start typing things, but that gets old real quick if you have to initialize your systems that way. So that's what I tried to show there, but failed. So that's about it. Resources there. LinuxContainers.org is where the Lxc project is. St. Graber. Yeah, Stefan Graber is one of the upstreams. Oh,
yeah.
That's nice. There he is. He and Serge Allen, who's on my team, are the Upstream Maintainers of Lxc. He wrote a 10-part, 9 of 10 are done, blog post series on features of Lxc. And if you want to look at it. I mean, it's really nice to read through it. He's done a good job of just showing some of the features. And then LWN.NET has got a couple different things. That one I think is on, that might be user namespaces, but you know, there's a lot of data out there for you if you want to read some more. I don't think I'll get into Docker, but Docker is, the word Docker, D-O-C-K-E-R, is another, if you just Google that, it's basically another interface into the same sorts of features, and it has become very popular. So you can also play with that. And that works on Ubuntu. Just boot it up, start it up, and start playing. Cool. That's all I got.